This presentation addresses the critical role of safety equipment and technologies in machines for worker safety. Information about safety distances used to enhance machine safety and the ISO 13857 standard is provided. The minimum distances that should be maintained between protective structures and hazardous areas to prevent body parts from reaching dangerous zones is examined. In this presentation, we will delve into the safety distances used to ensure machinery safety and the ISO 13857 standard in detail. While answering the question of what safety distance is and how it is calculated, the characteristics of guard fences and the distances between the machine body and the fence are also examined. Additionally, the use of light curtains, active optoelectronic protection devices, and safety distance calculations for light curtains are topics to be covered. Explanations about muting and blanking functions and recommendations are provided to help better understand safety measures. Designing machines safely is a vital step in preventing workplace accidents. It is mandatory to conduct risk assessments in the machine design process to identify potential hazards and take measures to reduce these risks. International standards, particularly the ISO 12100, guide this process. Machines are complex systems composed of parts and components assembled to perform a specific function. These systems must operate safely, be easy to use and maintain, and be equipped with safety measures that protect users from hazards. ISO 13857 is an important standard that defines the safety distances required to limit access to hazardous areas in machines. This standard is used to prevent workers and maintenance personnel from accidentally accessing the dangerous zones of machines. Various distances are defined in the standard based on different body sizes and machine structures. Safety distances are determined based on the speed at which workers' body parts can access hazardous areas. The ISO 13855 standard considers machine stopping times and operator access speeds to calculate these distances. For example, when using a light curtain, the sensor detection time should be adjusted according to the operator's movement speed. This case resulted in a worker losing their hand under a hot press due to incorrect safety distance calculations. Such accidents occur due to incorrect stopping time adjustments or inadequate safety systems in machines. Therefore, it is crucial to calculate safety distances correctly and test the systems regularly. All potential hazards that the machine may encounter throughout its life cycle must be identified. Possible risks should be considered at every stage, from manufacturing to operation, maintenance processes, and final disposal. Additionally, malfunctions and emergencies outside of normal operating conditions should also be included in this assessment. The distances left between the machine body and fences must prevent workers from accessing hazardous areas. Limbs may reach dangerous zones through wide openings, so these distances must be carefully determined. Periodic inspections are necessary to ensure that these gaps have not widened. Calculating safety distances accurately is a critical step in preventing workplace accidents. These calculations should be reviewed regularly, considering machine stopping times and workers' movement speeds. Additionally, full compliance with international standards such as ISO 13857 and ISO 13855 will enhance workplace safety. It is recommended that guard fences and safety systems be periodically inspected and maintained. Finally, regular training about safety distances and the safe use of machines should be provided to workers. This training will raise awareness and help prevent accidents. Thank you for listening. Please contact us for your questions.